I've spent countless nights like this, staring upward, neck craned, eyes searching the darkness punctuated by distant suns. There's something about this vastness that pulls at something primal within us. We're drawn to it like moths to cosmic flame, even as we know that same magnificent void could extinguish us in an instant. That's the paradox I want to explore with you today. Why do we find ourselves magnetically drawn to something that, by all rational measures, should terrify us completely? Why does space, this endless, airless, radiation-soaked wilderness, call to us with such persistence? And why, when we answer that call, do we find ourselves caught between transcendent wonder and existential dread? The distance between stars is almost beyond comprehension. Our nearest stellar neighbor, Proxima Centauri, sits over 4 light-years away, 40 trillion kilometers of almost perfect emptiness. I remember the first time I truly grasped this scale. I was 9 at a planetarium when the presenter mentioned casually that if our sun were the size of a pea, the nearest star would be another pea 700 kilometers away. Everything between? Void. Space is not just empty, it's actively hostile. Cosmic radiation streams through this darkness, unfiltered by atmosphere. Micrometeorites travel at speeds that would turn a paint fleck into a bullet. The temperature swings between scalding heat and absolute cold. The pressure differential would cause your blood to boil and your lungs to rupture simultaneously. Yet we dream of crossing it. We build spacecraft, train astronauts, write science fiction epics about traversing these deadly expanses. We've always been explorers, pushing into unknown territories. But space is different. It's the only frontier that could kill us instantly, without malice or intention, through sheer indifference to our biological fragility. Perhaps that's part of the allure. In an increasingly managed world, space remains genuinely, uncompromisingly wild. It demands our respect precisely because it doesn't care if we live or die. And somehow that honesty draws us forward, challenging us to find our place within its vastness. There it is, Earth, suspended in a sunbeam captured by Voyager 1 from 6 billion kilometers away. A pale blue dot, as Carl Sagan famously described it. Every person you've ever known, every historical figure, every human triumph and tragedy, confined to a pixel. I keep this image as my phone background, not as some nihilistic reminder of meaninglessness, but as what philosopher David Benatar calls cosmic insignificance therapy. There's profound relief in recognizing our smallness. Our failures aren't catastrophic on a cosmic scale. Our anxieties about status, wealth, or recognition dissolve against the backdrop of billions of galaxies, each containing billions of stars. But this same perspective that soothes can also haunt. If we're so small, do we matter at all? Is our existence, our art, science, love, creativity, merely sound and fury, signifying nothing against the indifferent cosmos? I've struggled with this duality. Some nights, looking upward brings peace. A gentle reminder that most of my daily concerns aren't worth the cortisol they produce. Other nights, the same view provokes a vertigo of significance. If the universe continues its expansion for trillions of years, after every trace of humanity has vanished, what was the point of any of it? Perhaps the answer isn't to choose between these perspectives, but to hold both simultaneously. To find meaning precisely in our capacity to create significance within a universe that offers none inherently. We are transient collections of stardust that somehow gain consciousness and the ability to contemplate our own existence. That paradox alone seems worthy of celebration. Astronauts who've traveled to space often return transformed. Frank White termed this the overview effect, a cognitive shift from seeing Earth as an abstraction to experiencing it as a fragile, borderless organism. Many describe it as profoundly spiritual, dissolving artificial boundaries of nation and ideology. Edgar Mitchell, after walking on the moon, founded an institute for noetic sciences. Rusty Schweikart said, "You recognize that you're a piece of this total life." Even the more scientifically minded astronauts report a newfound sense of Earth's vulnerability and preciousness. But there's another side to this transformation that we talk about less often, what I call the pale blue dot syndrome. When astronauts see Earth reduced to a small sphere against the vastness, some experience not just awe, but existential vertigo. Michael Collins, orbiting alone on the far side of the moon during Apollo 11, described being both exhilarated and terrified by his complete separation from all other humans. Several astronauts have struggled with depression upon returning to Earth. The contrast between cosmic perspective and mundane reality creates a dissonance that some find difficult to reconcile. How do you grocery shop normally after watching Earth rise from lunar orbit? How do committee meetings matter after seeing entire continents pass beneath your feet in minutes? This is the double-edged sword of cosmic awe. Let me share something truly unsettling. The universe is not only expanding, it's accelerating in its expansion. Since the 1990s, when observations of distant supernovae revealed this acceleration, we've been forced to posit the existence of dark energy, a mysterious force that counteracts gravity at cosmic scales. If current models are correct, dark energy will eventually push most galaxies beyond our cosmic horizon. In the distant future, inhabitants of the Milky Way, if any exist, will look out upon a nearly empty sky. Other galaxies will have receded so far that their light can never reach us. Evidence of the Big Bang will have stretched beyond detectability. Future astronomers would conclude they live in a small, static, eternal universe. This isn't science fiction. It's the projected outcome of observed physical laws. We happen to live in the brief cosmological window where we can still see enough to reconstruct our universe's history and future. Had intelligent life emerged a few trillion years later, they would be cosmologically blind, unaware of the vast universe beyond their local group of galaxies. I find this prospect both fascinating and deeply unsettling. Not only are we insignificant in space, but we're also transient in cosmic time. The universe itself seems designed to eventually erase the evidence of its own birth and evolution. We're not just small, we're ephemeral witnesses to cosmic processes that will continue long after we're gone, before ultimately fading into eternal darkness. There's something both wondrous and terrifying about being conscious during this brief window, when the universe is still observable in its fullness. We're like visitors who arrived at a vast library just before it begins systematically burning its collection, with just enough time to glimpse what's being lost. At the center of nearly every galaxy, including our own, lurks a supermassive black hole. Ours, Sagittarius A*, has the mass of about 4 million suns compressed into a space smaller than our solar system. Black holes represent physics at its most extreme, where Einstein's relativity and quantum mechanics collide in ways we still don't fully understand. I've always been fascinated by black holes because they're cosmic contradictions. They're the simplest objects in the universe, defined by just 3 parameters: mass, charge, and spin. Yet they're also the most complex, potentially connecting to other universes, storing information on their horizons, warping space-time into configurations we can barely mathematize. The event horizon of a black hole marks a boundary beyond which our understanding breaks down completely. Cross it, and causality itself becomes twisted. The future becomes as fixed as the past. Space and time exchange roles. Every path leads inexorably toward the singularity, a point where density becomes infinite and known physics ceases to apply. Black holes embody the dual nature of our relationship with space. They're objects of intense scientific curiosity that have driven theoretical advances. Yet they're also cosmic monsters that devour light itself, regions where the universe seems to open its maw and swallow existence whole. When I contemplate black holes, I'm reminded of the ancient cartographers who marked unexplored territories with the warning, "Here be dragons." We've moved those dragons from the edges of our maps to the centers of our galaxies, and they're more magnificent and terrifying than any mythological beast. We now know our galaxy teems with planets, Conservative estimates suggest there are more planets than stars in the Milky Way, at least 100 billion worlds. Based on what we're learning about habitable zones and the chemistry of life, billions of these could potentially support some form of biology. The discovery of a microbe on Mars or in the subsurface ocean of Europa would be the most significant scientific finding in human history. It would tell us that life isn't a cosmic anomaly, but perhaps a common outcome of chemical evolution. If we found complex multicellular organisms, that would suggest the path from simplicity to complexity might be common rather than exceptional. I've worked with astrobiologists who tear up at the mere possibility. Finding extraterrestrial life would end our cosmic loneliness, proof that the universe has produced consciousness beyond our pale blue dot. And yet, the same discovery could be profoundly unsettling. If simple life is common, where is everyone? This is Fermi's paradox, the contradiction between the high probability of extraterrestrial civilizations and our lack of contact with them. The solutions to this paradox range from reassuring to terrifying. Perhaps we're truly alone, the product of an improbable series of evolutionary accidents. Or maybe civilizations inevitably destroy themselves once they reach a certain technological threshold. Perhaps advanced life forms exist, but find us about as interesting as we find bacterial colonies. Or most disturbingly, perhaps they're deliberately avoiding contact for reasons we can't comprehend. The search for extraterrestrial life forces us to confront our place in the cosmos. Are we special or mundane? Are we early in the story of cosmic intelligence, or latecomers to a universe that's already been thoroughly explored? Each possibility comes with its own existential implications. When I look at the night sky, I'm not seeing the universe as it is, but as it was. The light from Andromeda left that galaxy 2.5 million years ago, when our ancestors were first learning to use stone tools. The photons striking my retina from the Crab Nebula began their journey nearly 1,000 years ago, when the Song dynasty ruled China. We're not just looking across space, we're looking back in time. The average star lives for billions of years. Galaxies evolve over hundreds of billions. The universe itself is projected to remain dynamic for trillions. Against these timescales, human civilization's few thousand years register as barely a cosmological instant. We're witnessing a cosmic moment, like walking into a movie that's been playing for 13.8 billion years, and will continue long after we've left the theater. There's an unsettling beauty in this perspective. Many of the stars we see are already dead, their final light still traveling toward us. Others are being born in stellar nurseries, their first light just beginning its journey across the void. We're seeing a universe that's simultaneously ancient and newborn, dead and alive. Our own sun will eventually exhaust its hydrogen fuel, expand into a red giant, and ultimately collapse into a white dwarf. Earth will be consumed in this process. Long before that, humanity will either have perished or evolved into something unrecognizable to us today. Everything we've built, written, composed, or discovered will be gone. This knowledge could lead to nihilism. Why create anything in the face of cosmic impermanence? Yet paradoxically, many find it liberating. The ephemeral nature of existence doesn't diminish its value. It may enhance it. A sunset isn't less beautiful because it lasts only minutes. Perhaps civilization isn't less meaningful because it lasts only millions of years. For over 60 years, we've been systematically searching for signals from extraterrestrial intelligences. We've pointed radio telescopes at promising star systems, analyzed light curves for signs of megastructures, and scanned our own solar system for evidence of ancient visitations. The result? Silence. A profound, persistent silence that grows more conspicuous with each negative result. This is what astronomers call the Great Silence, or sometimes the cosmic silence. It's the eerie absence of detectable technological civilizations in a galaxy that should, by reasonable probability calculations, host many. I find few things more hauntingly beautiful than SETI's waterfall displays, cascading visualizations of radio frequencies where we search for patterns amid the noise. These displays represent our collective ear pressed against the cosmic wall, listening for neighbors. So far, we've heard only the ambient sounds of a universe going about its non-intelligent business. Pulsars spinning, gas clouds collapsing, the cosmic microwave background radiation washing over everything. This silence provokes a particular kind of existential loneliness. We're calling out into the dark and no one is answering. We're sending radio waves, laser pulses, and even physical artifacts like the Voyager Golden Records into the void, with no expectation of response within our lifetimes. Are we truly alone? Or are we like isolated tribes in a vast jungle, each thinking themselves the only people alive, separated by distances too great to cross with their technology? Perhaps advanced civilizations communicate using principles we haven't discovered yet, their conversations passing through us undetected, like neutrinos through solid matter. The Great Silence reminds us that space is not just physically vast, but communicatively vast. Even if the galaxy teems with intelligence, the light speed limit ensures that conversations unfold over centuries or millennia. We might be part of a galactic community without ever knowing it, our messages crossing in the void like ships passing in the night, separated not just by distance, but by time itself. In the constellation, Orion hangs a cloud of gas and dust where new stars are being born. Through infrared telescopes, we can peer into this stellar nursery and watch creation in progress. Protostars gathering mass, planetary systems coalescing from disks of debris. These regions embody cosmic potential, the universe's capacity for renewal and complexity. Elsewhere in the Crab Nebula, we see the aftermath of a stellar death, a supernova remnant expanding outward at thousands of kilometers per second, carrying newly forged heavy elements into interstellar space. These elements, carbon, oxygen, iron, gold, will eventually find their way into new generations of stars and planets. This cycle of stellar birth and death reveals a profound truth. We exist because stars died. Every atom in your body heavier than hydrogen, helium, and traces of lithium was forged in stellar furnaces or during their explosive deaths. We are, quite literally, made of stardust. I find this knowledge simultaneously comforting and unsettling. Comforting because it connects us to cosmic processes, making us not just observers of the universe, but participants in its evolution. Unsettling because it reminds us that creation and destruction are inseparable aspects of the same process. Beauty emerges from cataclysm. Life springs from death. When I look at my own hands, I'm looking at atoms that have existed for billions of years. Atoms that once constituted other living things, other planets, other stars. My physical form is borrowed, a temporary arrangement of eternal ingredients. I'll return these ingredients to the cosmic cycle eventually, perhaps to become part of future worlds, future life forms. This perspective transforms how I think about my own mortality. My consciousness may be finite, but the matter that supports it is ancient and enduring. I'm not separate from the cosmic process, but integral to it, a brief pattern in the flowing river of existence. You develop an instant global consciousness, a people orientation, an intense dissatisfaction with the state of the world, and a compulsion to do something about it. This is how Apollo 14 astronaut Edgar Mitchell described what he felt orbiting the Earth. The overview effect, first described by author Frank White, refers to the cognitive shift experienced by astronauts when seeing Earth from space. It's not just an intellectual understanding of our planet's unity, but a visceral, emotional recognition that transforms how they relate to humanity, to Earth, and to existence itself. Astronaut Ron Garan called it orbital perspective. He described looking down at Earth during a spacewalk and being struck not by political boundaries, but by the paper-thin atmosphere protecting all life. If people could see Earth from space, he said, there would be a revolution in consciousness. This transformation isn't temporary. For many space travelers, it fundamentally alters their priorities and values. They return with a heightened environmental consciousness, a reduced tolerance for artificial divisions between peoples, and often a spiritual awakening regardless of their religious background. But the overview effect has its shadow side. Some astronauts struggle to reintegrate into society after experiencing this perspective. How do you participate in petty conflicts after seeing the unity of Earth? How do you justify national interests when you've witnessed our common fragility? I've often wondered, if sending a few hundred people to space can transform their consciousness so profoundly, what might happen if this perspective became widely accessible? Virtual reality and immersive dome experiences are attempting to democratize the overview effect. Could this shared perspective shift our collective priorities before we damage our planetary life support systems beyond repair? We began with this view, stars scattered across darkness, beckoning us outward. We've explored the contradictions inherent in our relationship with space, how it simultaneously diminishes and elevates us, how it provokes both wonder and dread, how it connects us to cosmic processes while reminding us of our isolation. Space is the mirror in which humanity sees itself most clearly. Not just what we are, but what we might become. It reflects our curiosity, our courage, our technological ingenuity. But it also reflects our limitations, our fragility, our cosmic insignificance. Perhaps the greatest gift of looking outward is the perspective it gives us when we turn our gaze back to Earth. From space, astronauts don't see national borders. They see a unified biosphere, fragile and precious against the void. They see humanity not as separate nations, but as a single species sharing a common fate on our pale blue dot. As we continue pushing into the cosmos, sending robots to distant planets, building telescopes that peer across time, perhaps eventually sending humans beyond our solar system, we carry with us this paradoxical relationship with space. We are drawn to it precisely because it both enchants and terrifies us, because it offers both transcendent connection and existential solitude. In the end, maybe that's the point of looking upward, not to escape our humanity, but to more fully embrace it. To recognize that our brief moment of consciousness in this vast cosmos is not diminished by the universe's scale, but made more precious by it. We are the universe becoming aware of itself, the cosmos contemplating its own existence through billions of eyes turned skyward in wonder. Fade to black.